Hello everyone. Today we are discussing IC engines for IMS-GOA interview. Okay. So should we start? Hello. Am I audible?
Yes, you are audible and clear. You can start right now.
Yeah, yeah. Okay. So let's start with the first question. Safety devices on the engine. Anyone would like to go ahead?
Please specify which engine, whether it is two-stroke or four-stroke.
Actually, the question hasn't specified like two-stroke or four-stroke. I have answer for four-stroke. Uh, if you know about the main engine, then go ahead.
Yeah, first, let someone answer.
Yeah, yeah, sure. Vinayak, Gulshan, Ashok. Hello. Pick up, guys. Okay, so the question was safety devices or alarms on the engines. Would you like to go ahead, Ashok?
So,
Shashank bro, I
no,
don't
I didn't know. So,
Okay. Yeah, Gulshan, you were saying something?
actually I don't know.
Okay. I think, Shashank, why don't you start with the main engine safeties? Then I'll talk about the auxiliary engine safeties.
Yeah, that's fine. See, there is a trick to remember the safeties. Okay, you just start with any running machineries. There will be lube oil. Any running machineries. You take compressor, you take generators, or you take main engine. All the running machineries will have lubrication in it. Okay, so wherever there is lubrication, so there will be always lube oil pressure alarm. That will be low lube oil pressure alarm. Not only alarm, there will be low lube oil pressure alarm and trip. There will be both lube oil alarm and trip both. Okay, this is one thing. So there is lube oil. And second thing is that, and this is engine, so there can be overspeed trip, like engine rating. Like example, your engine rpm is 100, but sometimes what if it will go more than 100 rpm, like it will be set around 112% to 115%, meaning at 112 or 115 rpm your engine has to slow down or trip. This is overspeed trip, sorry. At overspeed trip your engine will trip. So one is lube oil, other is overspeed trip, and third is there will be crankcase explosion, right? So for
Yeah.
preventing this crankcase explosion, there are a few safety devices. One is oil mist detector, and okay, this is enough for you guys. And there will be relief valves, guys, in engine. Relief door and relief valve both.
Okay.
And
Can you just talk something about oil pitch detector?
yeah, see what this oil mist detector does is it will take sample from all the units. Like there are 6 units, so it will take sample and it will measure the mist inside. If there is higher mist, then it will cause a primary explosion inside the crankcase. We don't want that to happen, so there will be oil mist detector fitted on board. So we discussed lube oil, then overspeed trip, then this oil mist detector. Leaving this, there will be relief doors. Okay, so 4 things we have
Okay.
discussed. Now, if we talk about other systems like fuel oil system, then there can be low fuel oil pressure alarm. Okay, we want for main engine fuel oil pressure somewhere between 7 bar, 7 to 8 bar. So if the lube oil, I mean fuel oil pressure drop, there will be
Pardon?
low fuel oil pressure.
What was the pressure of the fuel oil?
Fuel of it will be around 6 to 7 bar. I'm talking about the fuel pump pressure. Okay, but the injection pressure is around 250 bar, 250 350 bar. Sorry, in the injector the pressure is 350 bar. Okay, I'm talking about the fuel pump pressure. I mean fuel line pressure, not the fuel pump. Okay, now this one we finished. Then there is jacket. Jacket water. This one, jacket water high temperature trip. This is also there. We don't want jacket temperature to go very high. So whenever it goes, it will trip. Okay, this is also there. And other is like running in direction. I mean, this all not required. Uh, then other system like let us take now we finished fuel oil over. Then exhaust gas high temperature alarm is there. Okay, for exhaust. So in interview, what you can do is just remember the systems. Like, if you come for air, then starting air low pressure alarm is there. And yeah, if you can remember so much, it is well and good. Each system you remember one alarm, guys.
Okay. So right now the safeties in four-stroke engine which I have are somewhat similar, except I think in four-stroke engine we don't have base detectors, right, Shan?
Yeah, there is no oil mist detector in four stroke.
Yeah. Otherwise, we have overspeed trip, then jacket water high temperature alarm and trip, then we have lube oil low pressure trip, then crankcase refills are there in both the engines, then high exhaust gas temperature are there in both the engines, right?
Yes.
Yeah, these five are common in both engines. Plus, main engine will have oil-based detector.
Yeah, there are other things also, but if you can remember these things, it is fine. Like
Okay,
interview
fine.
will ask only like 5 or 6. If you tell, it is well and good.
Okay, okay. So, anyone would like to go about it, or we should move it to the next question? Anyone has any question?
Can you drop the name of four safeties on comment box?
Uh,
Yeah,
I'll put it on the group. Is that fine?
Okay, okay.
I'm just putting the photo on because I have written it.
Hello.
Yeah.
What if the exhaust gas temperature is high? What will happen?
see, there are two things, bro. One is shut down, other is slow down on the engine. Okay, generally these kind of alarms will slow down the engine. It will not shut down. Shutdown is only when there is overspeed trip and this lube oil low pressure alarm and trip. During that time, it will shut down completely. Other time, it will just slow down. By the time, you will have to rectify the problem.
Okay, bro.
Shashank, can you just explain what will happen if the exhaust temperature is high, or what
Why?
it indicates?
If exhaust temperature is high, there could be various reasons, bro. You should see whether the exhaust temperature is high in all the units or it is only high in the particular unit. If it is in the particular unit, then you may suspect that inside that unit there can be this one. What is that? Scavenge fire. Okay, and combustion is not happening proper in that unit. So these things you can suspect. But if it is in all the system, like all the units, the exhaust temperature is high, meaning it is a common problem. Then you have to check the fuel line and air line. So this is overall this one. What is it? Troubleshooting part. You don't have to worry about this.
Okay.
Yeah.
No, I was just confirming. Okay, Jackpot, go ahead.
It might be also jacket cooling water in.
Yeah. About the jacket. So generally we maintain jacket temperature like 80 degrees for main engine. 82, 81, 82 like this.
Okay, so we can say if there is a improper combustion, that will have exhaust gas temperature high, right?
Yeah, not just that. There are various reasons.
Yeah,
Anyways, I'll put that reason in the
broadly,
group.
broadly,
Yeah.
broadly.
Yeah, I'll put right reasons in the group later. You can check.
Okay, sure, sure. Okay, so let's moving on to the next question. That is the camless engine. What are the camless engines? Anyway,
ME engines.
yeah. Please pick up.
Valve is run on a electric actuator in HEMI engines. That's why it's called camless engine.
Yeah. It can be either electric or hydraulic, and I think there are pneumatic systems also which are operating the valve. Am I right, Shriram and Jackpot?
It is both hydraulic and electronic. Both are mixed together.
Okay. So instead of operating the valves and valves with the help of a camshaft, we are using the electronic and hydraulic systems to actuate the valve. Okay. It gets a more precise actuation of valve so that we can time the ejection and opening and closing of the exhaust valve. So we get better efficiency and functioning of the engine, right?
Exactly.
Okay.
You can vary the timing of the opening of the valves and fuel injection, so you can achieve maximum efficiency of the engine.
Right. Yeah. So basic engine question. Okay, we'll come to that later. Anyone would like to ask basic engine questions? I think there'll be most likely about the types, then components, etc. The questions are listed further in this list. We go to the next. So how does the propeller is rotating? As far as I know, in the ship, the propeller is directly coupled with the engine's crankshaft, and they're running at 1:1 ratio, right?
Yes.
How to reverse an engine? By reversing of engine is basically done by changing the firing order of the cylinders. It can be
By
done by changing the
hydraulically
crank
moving
profiles.
the cams.
Yeah. So basically, on the ships, we have two cam profiles. It is connected to a hydraulic system. Using that system, we can change or move the shaft in particular linear directions. So whenever we are trying to move the engine in forward or reverse, we just shift the move the hydraulic camshaft with the hydraulic system, and so that we get the change crank profile. So our firing order changes, and so the rotation direction of the engine is changed.
How does the crankshaft will change the position?
Camshaft.
Sorry, crankshaft.
Okay. See, for changing the direction of the engine, what we are doing is changing the firing order of the cylinders. Okay.
Okay.
So for doing that, we need to change the cam profiles. Basically, we need to change the timing at which the exhaust valve or fuel injection is happening. Is that clear?
I didn't get you. Can you share any diagram related to this?
Diagram. Okay. Diagram. Jackpot, until I search for diagram, would you like to answer the question in more refined way, if you have?
Who asked the question?
Me.
Ashok.
Ashok.
Yeah.
So totally, you are asking about the two-stroke or four-stroke?
Two-stroke main engine. The crankshaft is connected to the piston. Meanwhile, changing the firing order, how does the crankshaft will move the piston?
Can you clear with the camshaft or crankshaft? Can you clear the
Crankshaft.
crank?
Yeah.
Crankshaft is connected with the piston, but camshaft is connected with the crankshaft. Cam and cam, two different terms. Cam is controlling the fuel injection and exhaust valve opening of the two-stroke.
Yeah.
Okay, are you good with it? Do you understand that?
Yeah, I understand that.
So, okay, right now you have to reverse the engine.
Okay.
For that, you have to change the air distributor first.
Okay.
It's all connected with the camshaft only. There are profiles, two sets of profiles, one for the forward and one for the reverse.
Okay.
For normally for a single unit, if you have two cams for fuel injection and exhaust valve opening,
Okay.
for the forward. For reverse, there are two. Okay, totally four for the single unit.
Totally four valves. One is inlet and
4
outlet.
cams.
Oh, four cams. Okay, okay. Four cams.
There will be no inlet on the two-stroke. There is scavenge.
Okay.
Mm. The cam profiles are changed by the hydraulic unit. When you press a button from the bridge, it will hydraulically move the cams, adjust the cams to the reverse firing order. So the firing order will be changed by the air distributor.
Okay, okay. We manually change the by using electronic
Hydraulic.
hydraulic actuation. We change the firing order of.
By
Okay.
changing the cam profiles.
Okay. Okay, and now I
Ashok,
get it.
yeah, right now I couldn't find a diagram or something, but I have one video. I'll share it later on the group. Okay.
Okay, Bhagwan, thanks.
Yeah.
One more thing to add in this, like you're not changing your exhaust timing or scavenging timing. You're only changing two things. You're changing your fuel injection timing and you're changing the air. Like when you're starting the engine, your
Air
transmission
distributor,
engine.
right? You are speaking about.
Yeah.
So what was your question in it?
Somebody told that you will change the exhaust timing as well.
Exhaust timing will be same only for the forward and reverse, but the firing order will change, so the exhaust timing also change. Not the time, exact timing. Okay, if the firing order only according to that only exhaust timing will change.
Little bit confused over here. Uh, I didn't get exactly what you were saying, Shashank.
Nothing. Fine then.
And there will be a slight change in the exhaust valve timing right now.
See, exhaust valve timing and scavenge. If you see your two-stroke diagram, like
Valve timing diagram.
the valve timing diagram, in that you can see that exhaust timing and scavenge timing, they're almost same. If you're changing
Yeah.
the direction also, it will be same only.
Okay.
The only
So
thing
there
you're
is
changing is your fuel injection and starting air. Only these two things you are going to change during.
okay. So we can say that you are just changing the firing order to reverse the engine.
Yeah.
Okay. For that add. Okay. So next, what is lubrication and types of lubrication? And also I'll add another question to the same thing. What parts are lubricated? Okay. Anyone? Anson? Hello. Hello. Am I audible?
Yes,
Yes, you are audible.
Please, guys, respond something. What's the point of this good discussion? We are just two guys are talking.
So let's continue.
Yeah, yeah. So the question was, what is lubrication and types of lubrication?
Can I?
Yeah, sure. Go ahead.
The lubrication is the flow of oil between two mating surfaces having relating motion. Is this right answer?
Yeah, yeah,
And the types of lubrication are mist lubrication system, wet sum lubrication system, and dry sum lubrication system. In wet sum lubrication system, there is splash lubrication, semi pressure lubrication, I think, and full pressure lubrication.
yeah. So in types, you just mentioned like first, what was the first type?
Mist lubrication system.
Okay. Do you have anything more to tell about the mist lubrication?
I don't really know about that, but I mug up in I that information is on my book,
Okay.
my 7th semester book IC Engine. So I mug up in that. There are really they elaborate the wet sump system, splash lubrication, and dry sump lubrication. So I really don't know about the mist lubrication system.
Okay. Yep. Go ahead, Jack.
Is there any mist lubrication system?
Actually, I heard that for the first time. That's why I was asking.
Me too. I'm hearing for the first time.
As far as I know, there are splash lubrication, then there is dry lubrication, and wet some lubrication. These three only I know.
Yes, yes.
Your
Can I
question is
send a photo in group
Yeah, sure.
about this
Why not?
lubrication system?
you're asking
Okay,
about the
okay.
question types of lubrication, right?
Yeah.
Hydrostatic, hydrodynamic lubrication, like that only come, right?
Okay. Can you try to answer the question, please? Jack.
Hydrodynamic lubrication, hydrostatic lubrication.
Right.
So okay, it's a marine terms. Okay, leave.
Okay, I see. Why don't you just pick up for that? And it will be better. Hydrodynamic, hydrostatic, mixed, and boundary.
Don't need to confuse you them. Leave.
Jack, if you can just describe these types within 1 or 2 lines, if possible.
No, bro. They will get confused.
I just sent a photo in group.
Okay.
Hey, I found some information about mist lubrication system.
Okay.
There is written that the mist lubrication system is used for two-stroke petrol engine in which 2 to 3% lubrication oil added in the fuel tank. The mixture oil and petrol sucks through carburetor. The fuel petrol is vaporized and oil is in the form of mist goes through crankcase into the cylinder. That is about mist lubrication. Let me send you the photo. So
Yeah, we get that. That's why we mixed oil in the two-stroke fuels. Yeah, we just didn't know the term mist lubrication. Okay. So right now, that's it about the lubrication. Then there is one question, but I'll take it later. Okay. So types of IC engines. Anyone would like to go with this question? Anyone?
what you said? Types of IC
Types
engine?
of IC engines. Yeah.
Okay, the IC engine is classified as first of all the types of fuel use. There are where there is a petrol engine, gas engine, diesel engine. After that, we can classify IC engine in the as a thermodynamics, like Otto cycle, diesel cycle, and dual cycle. Dual cycle, sorry. Further, we can classify IC engine into as per number of strokes, as that is a 4-stroke and 2-stroke engine. After that, we can classify IC engine into methods of ignition, that is spark ignition and compressed ignition system. Further classified into methods of cooling, that is air cooled and water cooled. And last, I know that as we can classify IC engines into speed of the engine, that is low speed engine, medium speed engine, and high speed engine. Am I right?
Yeah, that is a very elaborated answer. Yeah. So just correct me if I'm saying anything wrong. Is there, should we mention like CI engine, SI engine, and then auto cycle and diesel cycle engines? Because CI engine, diesel cycle engine, and also what what was the another type? Fuel based on fuel, the diesel engine.
Based on fuel, yes.
Yeah, so it's the same categorization, I think, right?
Yes, yes. We can say there are almost same.
Yeah, yeah. So if we
It
have
is.
to
We
narrow
can
it
use
down,
there. What?
if we have to narrow it down, then we can say we have diesel engine, we have petrol engine.
Yes, yes.
Also, we have like two-stroke engines, four-stroke engines.
Four-stroke engine. Yes.
Yeah, and there is another classification I would like to add in because there is mention of Wankel engine afterwards.
Yes, yes.
So there is rotary engine and like reciprocating engine.
Yes,
Okay.
yes, yes. We
We'll
can
talk about
mention that.
rotary engines further in the discussion. Yeah, and someone just also mentioned naturally aspirated and turbocharged. Yeah, that can be also added. Right. The next question is, what is rocker arm? Yes, you see, these engines are like basically this classification is done as per the arrangement of the multi-cylinders and say, arrangement of the cylinders in multi-cylinder engine, like the radial V engine and W. Radial engines are generally used in like the older airplane engines. Yeah. So anyone was so the next question I asked was rocker arm. What is rocker arm? So can anyone explain?
Can I?
Yeah, well,
Rocker arm is a component is in internal combustion engine. It is responsible for the transmitting the motion of the camshaft to open and close the engine's intake and exhaust valves.
yeah. So I'll try to answer in like a different, slightly different arrangement. So rocker arm is basically a layer-like arrangement provided in the head of the IC engine, which takes motion, which transfers the motion from the camshaft to the poppet valve, and it is responsible for the opening and closing of the valve. Is that right?
Yes, yes, right. We can mention also that.
So valve timing diagram. Anyone would like to explain valve timing diagram? If you can pick anything, like post or two flow. Ayush, Ashok? Hello?
It is mentioned the when was the inlet valve and closing the valve. It is also mentioned how the compression and then exhaust
Yeah,
flow
I mean,
is.
if you can like just share, I'll just share the image on the display and then try to. Would you like to explain how it is done?
Okay.
Yeah. So which diagram should I find? Two-stroke or four-stroke?
Two-stroke.
Okay. Is the screen visible?
Yeah, it's visible.
Yeah. It is possible that the degrees mentioned here can be slightly different from whatever reference material you are using. Go with whatever you have on, what you have prepared. Okay.
I start from exhaust opens. When there is a exhaust opens and then pistons move from bottom dead center to when there is a exhaust opens, the inlet valve opens and then piston move upwards. The scavenging process is take place. When there is moves to which is middle of the, I didn't answer that correctly. So sorry.
Take your time. Would you like to try again?
No, I can't recall it. So go on.
Anyone else? I'll just try to answer it. So the cycle starts when piston is at the bottom dead center. Okay. So as the piston starts moving upward, the exhaust gases or like after gases remain residual gases which are present inside the cylinder are pushed out of the exhaust fan. These gases are present because of the previous cycle. Okay. So somewhere around like 35 degrees after BDC, scavenge port is closed. Okay. Then somewhere around like 50 degrees, exhaust port is closed. Right. The piston reaches to like near the TDC. So before 10 degrees, piston reaches the TDC. The fuel injection is started, and it continues till the like 30 degrees after TDC. Okay. So uh, after that, combustion process happens, and like then piston starts coming down. So moving towards the BDC. So before BDC, like 50 degrees, exhaust valve is open. Then exhaust like scavenging process starts like somewhere around like 50 degrees before BDC, and again the cycle continues. Like, this latest BDC, exhaust gases are thrown out, and again the fresh charge comes in, it compresses. Then fuel injection starts 10 degrees before 30 degrees and continues till the 30 degrees, and then combustion takes place. Okay, I think I need to print answer both. Test. Stop the screen sharing. Anyone would like to explain four-stroke timing diagram? Hello. Hi, Ritik.
Can I?
Yeah, go ahead.
Okay. Inlet valve opens 20 degree before TDC and inlet valve closes 60 degree after BDC. Then then ignition starts 10 degree before TDC approximately, and ignition stops 20 degree after TDC approximately. After that, power stroke happens. After that, exhaust valve opens 42 degree before BDC and exhaust valve closes 60 degree after TDC.
Yeah. Shashank and Record, I would like to ask you two guys. I have seen that these values of angles are somewhat different from like material to material. In some book, it's mentioned like 30, 40, 25.
No, no,
In
no.
some
It's
books,
it varies according to the engine. So
So
each
it is
book should
total.
refers one on engine, so it will vary according to that.
Okay. So whatever
Better
we
you
have
follow
defined,
this.
we should go with it.
Better you follow this McGeorge textbook or Pounders, any of the textbook.
Okay. Yeah, sure. Because had it from I think the reverse. I not so from the reverse. It's slightly different values. I think it's fine, right?
Yeah, it's fine only because they are giving according to their engines. Okay,
Yeah,
the
yeah.
wall timing will be vary to various engines.
Okay. Uh, then there's next question is about how to explain the size of an engine using PHP. Is anyone able to find the answer?
Actually, we can measure the size of the engine by PHB, but there is not exact rule for it. This is just an assumption. If PHB is high, then we can assume that engine may be high, engine size may be high. If PHB is less, then it's also assumption. We can find that the engine size may be less. But there is not any rule, but it's just an assumption.
What's your take on this?
I'm not sure about this, bro. First time.
Yeah, actually, I was a little confused there because, as Atif said, it's like there is not exact formula to convert your like you cannot calculate exact like the
We can
stroke length.
find from IHP, bro.
Yeah.
Yeah. From IHP you can find it.
Yes,
PLN,
yes.
then you can find the area and all that stuff.
PMLN.
But from PHP,
PMLN upon
16.
4500. Na na. IHP na.
Yeah.
BHP is the power available in the shaft
Yes,
at a
yes.
particular RPM.
What's the formula, bro? Up upon
PL,
600
PLANK.
16,000 or 4500.
It's very sorry for that. Yeah. So what we are in PLAN upon T or like time watts. You get power in watts. So P is mean pressure, L is stroke length, then A is bore area, then N is number of RPM. And if you are converting it into the HP, then you have to divide this entire thing with 746. That- so the conclusion of it, you cannot exactly determine the dimension of your engine using base. Am I right? Okay. Let's just move on to the next question. Which type of engine is used on ship and why?
Two-stroke diesel engine are used on a ship because it has a long, strong strokelet which is used for heavy fuel oil, and two-stroke diesel engine is bi-direction which will help for propulsion.
What about four stroke?
for a auxiliary like in a generator.
So for main engine for propulsion and use four-stroke for auxiliary engines.
Two stroke has a
So
longer stroke, so it will easier to burn the HFO.
No, bro.
exactly
No,
this.
no, no, no.
Are you sure
It's
that?
Ashok, right?
Yeah.
No, bro. It's not for that long stroke. You are using HFO also in four stroke also, right? What do you say? Auxiliary engine generators.
But the efficiency as compared to two stroke and four stroke is two stroke is a longer efficiency.
Longer efficiency. Yeah. No, it's no high power.
Okay.
Okay, so Ashok,
Both
as far as
both
I
the
know,
engines using only HFO only. Don't say
yeah,
that
yeah,
in interview.
yeah. So in case if you're talking about the efficiency, then two-stroke engines are like more efficient at slow and constant RPM. Okay.
Okay.
One reason is someone mentioned, I think it was Abhay. So one reason is it can be reversible. Then second reason they are like slow speed engine. Third reason is the torque. They offer more uniform torque.
Oh, okay. It produce more power in one crank, in one revolution of crank.
Yeah.
Okay.
I think three reasons are sufficient, right, Jack?
Yeah, reasons are sufficient. You want to know why two stroke is better to propulsion.
Yeah.
For long stroke, it has more power. You know, right? Plan
Yeah.
power, length, bore, number of RPMs.
Mhm.
If you increase the stroke length, the power will be increased. That's why they are using two stroke, super long stroke. If you take the size of the main engine in the bulk carrier and the container ship has a bigger size main engine because it needs more power to propel the container ship.
That was beautiful addition. Thank you. Uh, Now let's get to the next question. Can we run ship on four-stroke petrol engine?
Yes, possible if you use reduction gear.
But as a fuel,
But
petrol is not used on engine room. Any fuel which has flash point lesser than 60 cannot be used in engine room. So you cannot use the petrol engine as a four-stroke propulsion engine. You can use four-stroke as a propulsion, but you cannot use petrol as a fuel.
okay. Basically, we have to make, the flash point is the limit, right?
Yeah, if it is flash point less than 60, you cannot use it
Okay.
because engine room temperature is like 40. So you take like that. And petrol can, it is more volatile. It can evaporate even at minus 23 degree also. So we cannot use petrol in engine room as it is a fire hazard.
Then what is crank wave?
What?
What is crank wave?
I didn't get the question, bro.
What is crank wave? CRANKWEB.
Crank web.
Yeah.
Crank web the crank pin to the main channel.
Uh, Sorry, we couldn't hear
Am
you
I
properly.
right? Am I right?
Can you repeat? Can you repeat, please?
Crank web channel.
Can everyone see the image I have shared? Hello.
Yes, yes, yes.
Yeah, so this portion over here is the crankwheel, which is like it connects the crank pins to the crank journal. And let's move on to the next question. Firing order inside the main cylinder, main engine cylinder. Yeah, so the next question is firing order in main engine cylinder. Assuming it's a six cylinder engine, it should be something like 1544642, right? We fire alternating pistons like
153624.
1 6 1 3.
153624.
Yeah, 1546. I think I said 4. So does anyone know how, like, why it is done like this and why we can't fire like 1 2 3 4 5? Anyone? Shashank?
Rotation will be improper. Rotation of the crankshaft will be improper.
See, during starting, different cylinders will be in different position. Okay, at least if we are having these two, right? At least two cylinder in the TDC position, you can easily crank the engine. There has to be certain cranking speed to start the engine.
Okay. So
For that,
basically,
yeah, for that the firing order should be like, at least when it is starting, out of 6 cylinder, at least 2 cylinders should be in the TDC position.
yeah, and another reason is like to avoid like excessive concentrated pressure on the crankshaft. Like if you have firing like from one end to another, then the pressure and heat, like stresses will be developed from on the like, concentrated stresses will be developed on the crankshaft, right?
Yeah, you can answer.
Yeah, it can be one of addition to your answer. There is another reason is like if you are trying like we can design the crankshaft accordingly. Like we want to fire 1 2 3 4 5 6, so that I want the crankshaft so that the first and second will be on the top and after like okay. But if you are doing so, what will happen is there will be excessive stresses. Like first engine is firing, first cylinder is firing, like second cylinder is firing. Then in this like this region there will be stresses, and on the right, like other region there won't be that stress. So what will happen? There is chances of deflection or damage to the crankshaft. So
Yes,
that's
yes.
another reason.
Well understood.
Yeah. Next is what is tappet clearance and why it is provided. Basically, tappet clearance is clearance provided between the valve stem and rocker arm, and it is there to compensate for the thermal expansions. Okay. Then the next is two-stroke versus four-stroke difference. And would like to talk.
In two-stroke engine, there is a one power stroke and one revolution of a crankshaft. In a four-stroke engine, there is a one power stroke and a two revolution of crankshaft. Two-stroke engines are a low-speed engine. Four-stroke engines are a high-speed engine. Uh, two-stroke two-stroke engine thermal efficiency is low, and four-stroke thermal efficiency is high due to there is a there is a there is a in a four-stroke engine there is a scavenge stroke individually. That's why their thermal efficiency is high. In two-stroke engine, mechanical efficiency is high, and in four-stroke engine, mechanical efficiency is low.
Size of flywheel is different. Two-stroke has lighter flywheel. Four-stroke has heavier flywheel. So two-stroke occupies the lesser floor space. Okay. Weight to power ratio is more in two-stroke as compared to four-stroke. That's fine. And you can find it anywhere on the network. Anyone would like to explain four-stroke engine working? Working of a four-stroke engine. Live. Yeah. So
Can I try?
yeah.
I start with the BDC. After the exhaust stroke, the after the combustion, the piston is in BDC. The exhaust valve is open, and then piston go upwards, and then inlet valve is opens. Where there is a light combustion air will get out of the exhaust gas, and then 100% of fresh air is get in, and then inlet valve closes after 40 degrees TDC, and then it comes to BDC, and then it will compress the exhaust valve, and then inlet valve closes. Compression stroke happens. After the compression stroke, the spark combustion compression stroke happens. After that, piston is go BDC to TDC, and then combustion stroke happens, where there is a spark ignition in plug is ignite the fuel and ignition, and then after that piston go downwards, and then go upwards for the exhaust stroke.
I think Ashok, you have to go through it again and mention which type of engine you are explaining. So like if you are explaining the SI engine, then there will be slightly different. Like there will be a spark plug instead of fuel injector. So mention it first. Like okay, I'm going to explain uh, SI engine. Okay. So if I'm going to explain SI engine, I'll go like okay. In the first stroke is suction stroke. Piston comes from TDC to PDC. Inlet valve is open. It sucks in the charging air. Then piston goes from like the second stroke is compression. Piston goes from like BDC to TDC. It compresses the air which has been sucked in during the suction stroke. Then uh, during the suction stroke, it sucks in air and fuel mixture. Then it is compressed in the compression stroke. Then spark ignites the fuel. Then power stroke takes place. Piston moves downward. During the stroke, both the valves are closed, but at the exhaust stroke, while a piston starts moving from BDC to BDC, exhaust valve is open, and the exhaust is thrown out of the combustion chamber. Yeah. And in case of the four-stroke diesel engine, what's happening is piston is sucking only air, then air is being compressed, then fuel injector injects the fuel, and auto ignition takes place. Power stroke happens, piston leans downward, then uh, for the exhaust stroke, piston starts moving upward, exhaust valve opens, gases will be thrown out. Okay. What is turbocharger? And why do we use turbocharger?
Turbocharger is a device which is used to increase the density of the air. The, the, the exhaust gas from the exhaust gas manifold is goes to the turbine. It rotates the turbine. The turbine and the centrifugal boilers are connected in same shaft. Due to that, the air get compressed. When the air get compressed, the temperature also increase. So there is a cooler is fitted after the blower. The cooler reduces the temperature of the air and to increase the efficiency, it also increase the density of the air. Ultimate purpose is to increase the efficiency of the air by increasing its density.
Increase the efficiency of the engine.
Yes, efficiency of the engine.
So it takes the residual heat from the exhaust gases, rotates the turbine, uh, then it's connected on the same shaft. It compresses the intake air, then it passes through the intercooler, so the temperature is reduced and we get higher density. And this high density air will be then provided for as a fresh charge to the engine. So this improves the efficiency and economy of our engine, right? Okay. The next question is why? What is function of flywheel?
Flywheel is a type of energy storing element. It stores the element during the power stroke and gives the power during other strokes. It's
Flywheel is a big weighted disc which is connected with a crankshaft, which is store the energy while the uh, engine is run and torque to the give a torque to the engine while it's slow down.
It will give the power to the crankshaft whenever the power power stroke is not happening. Am I correct?
Yes. So basically, flywheel's function is to like absorb the energy in the form of momentum during the power stroke, and then provide this energy back to the crankshaft during the other three strokes or other two strokes where we aren't getting proud. So it helps in like maintaining the uniformity of the torque. If we are not using the flywheel, then there will be jerks, and possibly we won't get the uniform rotary motion and outlet of the crankshaft. So that's why we need flywheel to balance the rotation and get uniform torque. Yes. Then what is Wankel engine?
What was the question?
What is Wankel engine? Wankel. Like, have you seen Wankel engine anywhere on board ship? It's a type of rotary engine. It's been used in some of the sports cars, in some type of
Never heard of it.
aeroplanes, etc. Yeah,
Never heard of it, bro.
I'll share the small chip. I don't think we have studied in detail, but it's hybrid engine. I think all of you can see this, right? So instead of piston cylinder arrangement, it has a rotor and casing. The rotor is kind of triangular shape, but it has curved edges slightly, and compression is happening between the face and the casing. So you can say air comes in, it gets compressed, then spark happens, power stroke and exhaust. So it's
What was the name of the engine?
Wankel, Wankel.
Okay.
It has been used, I think, in some cars like Mazda cars are using it, like XS7 or something, name of that car. There are some planes which use this type of engine. It has like a improper combustion. So thermodynamics is like pretty weak. Like thermal efficiency is weak. The exhaust gases has like a bad characteristics. Like it contains some unburned components, etc., etc. So that's why it is not very widely used in automobiles. I think that's enough for how it looks and how it operates. That's enough. So timing diagram and PV diagram we have provided. Then parts of main engine. Anyone?
Piston rod, crosshead, low head bearing, connecting rod, stuffing box, crankshaft, and crankcase.
Okay, have you
Bro,
mentioned the back?
go from outside, bro. Go from outside. Like bed plate, A-frame, entablature.
Yeah, that you are specifically explaining the use of marine engine. Marine engine with a I mean, you can do that also, but if you are mentioning any or like general engine, then start from one end and go to the like start from the top or start from the bottom. So there is less probability of you missing something. If you are just explaining a diesel engine, like start from top. You have exhaust valve, you have inlet port, inlet valve, then you have fuel injector, then you have piston, you have cylinder, you have cylinder liners, then go with like gudgeon pin, then you have a connecting rod, then you have crankshaft, then you have a flywheel, you have oil sump. These are general components. Have I missed anything important? Yes, sir.
No, bro.
I think that should suffice, right?
Basic things all you covered.
Yeah. So if you have know about the proper like, specific diseases, then go for it. But be prepared for cross questions. I suggest go with regular automobile engine. It won't have any issue. Then there is one question that has been asked: what is piston curl? Does anyone know? What is piston curl and why it is provided? I don't think anyone else is interested. Okay, go ahead, Jack.
It is used to reduce the side thrust.
Okay. Basically, that this portion which like protrudes down from the sides. So it ensures that your piston is moving upward and there's minimum launch, lateral movement. Right, Jack? By side thrust, you mean the horizontal movement, right?
What?
By side thrust, you mean horizontal movement, na?
Yes.
Yeah. So it ensures that your piston is moving like vertically as much as possible. So there will be less amount of stresses. You can see it on the screen. So generally, it has a piston skirt, piston skirt, which is like the walls, which is like a wall type section you can see here. Then there is rings. There are three types of rings: oiling, compression ring, then stripping ring. Then there is uh, indentations provided on the top, like the head of, crown of the piston. It facilitates like the movement of valves. Also, it helps in the mixing of charge together. What is it called? Gives the desired turbulence. So the air and fuel gets mixed properly. So the compression ring ensures that there is tight seal between the cylinder liners and piston. Oil control ring maintains uniform layer. Yeah, stepping range is there also. Steps of excess. That's all about piston. Rocker arm arrangement. We have discussed it before. There is a sort of a lever. One arm is connected to the piston head. Second end is connected to either a cam profiles or push rod. And push rod is basically extension which connects cam profile and this rocker arm arrangement. Okay. So next is, what if no tappet clearance is given? Or tappet clearance is not appropriate. Anyone Ashok? Seen? Vinay? Hi Rudik, how are you? Yeah, Ashok, go ahead.
I didn't know. You go on.
Okay. So this has been explained before. So basically, tappet clearance is clearance provided between the valve stem and the rocker arm. Yeah, go ahead with it.
Hello.
Yeah,
Uh,
go ahead.
when there is no tappet clearance given, then instead of valve expanding outward, it will expand inward, and it will cause leakage during compression stroke. So it is
Yeah.
necessary that tappet clearance is must.
Yeah, it is necessary to provide proper tappet clearance, because if it is not, then what will happen? The valve will not close where it should close, and there will be leakage, or like valve will. There is chances that if the tappet clearance is less, then the valves will remain open for longer time. Okay, and if it is less, then valve will not be open for sufficient time. Okay, so that's why we need exactly proper tappet clearance, and it is measured by slip gauge. Nice to see you again, Ritik.
Yes, yes, good to see you.
How fuel injection work? Are they expecting the proper explanation of how fuel injector is working? Anyone has an idea about it? Question? Fuel injection working? Anyone? How crankshaft and tankshaft are connected? Via chain drive or gear drive, belt drive also. Then purpose of seawater engine is generally used for cooling purpose, cooling of jacket. Seawater. There. Just correct if I'm wrong. For cooling water in jacket, we are using fresh water, right?
Yes.
Yeah,
Yes.
and where seawater exactly being used?
What was your question? What was your question?
The question purpose of seawater in engine. Okay, the answer I found was it's for cooling purpose.
Yes,
Seawater
it
in
is.
the
Yes,
engine.
it is.
I didn't get the question, bro.
The question is what is purpose of seawater in engine?
No idea. They won't use seawater in the engine. They use only
Yeah,
fresh
because
water.
there's because of the corrosion and clogging. So as far as I know, we are using fresh water as the jacket water for cooling purpose.
And seawater is used to cool the fresh water
Yeah,
in the central cooling system.
right. Like how the IHP is calculated. PLAN upon 60. You will get it in wax and the respective conversion factor. Okay. Then the next question is types of engine is being used. We have covered it. What is auxiliary engine and why it is used? So basically, auxiliary engine is four-stroke engine used to drive the generators.
Mainly for electrical purpose.
Yeah, yeah,
Because we need higher RPM.
yes. Then what is EN? Total base number. Uh, Total base number is like indication of basic additives inside a oil sump, lubrication oil sump provided in the crankcase. So it is given so that to neutralize this, it neutralizes the acidic contents which are being formed because of the process of combustion. So it's generally sulfur is present in the HFO, then there will be formation of sulfuric acids or something. So to neutralize that, we add some basic components in the oil. So integration of that is total base number. Am I right there?
Yes, you are right. But they are using mainly in the cylinder lube oil.
In the
Cylinder lube oil.
okay, so we don't use basic oil in the sump.
There will be varies. The lube oil will be vary. Cylinder oil is different, lube oil different. Cylinder oil has more TPN compared to lube oil.
Okay.
And
Can you give
lube
me
oil
the figure
using
if
two
you have?
stroke and four stroke is different.
Okay. I think the cylinder oil has higher TPN, no?
Yes.
Yeah, it is of much higher quality than the sump oil. Okay, so how exhaust valve is operated using the rocker armor event and with the help of camshaft? Clear the tappet. Thank you. We have done that already. So how piston is cooled?
Lube oil.
Yeah. Lube oil is there, and second is it like transfers some of the heat to the liners with, like through the compression rig. So that's also you can mention.
Basically, the piston is a hollow object. The lube oil went inside the piston and cooled the piston.
Yeah.
What?
I think your voice is cracking.
Voice is
Again,
breaking.
not
Can
very
you
proper.
put a message?
Yeah. Okay. Question is how bearings, main bearings are lubricated. Main bearings is like bearing between crankshaft and the connecting rod, right? Yes, sir.
What was the question?
The question is how main bearings are lubricated.
Main bearings are fitted,
Lubricated. It
lubricated.
will be better. Yeah, it will be better if you can mention the location.
Wait, I will give you the picture. Main bearings are lubricated by the hydrodynamic lubrication. And
There is a splash lubrication,
Ash,
right?
what?
The splash lubrication, no?
No, 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 no. In two-stroke, no splash lubrication.
Okay.
And Ashin, for asking about the piston cooling, right? We cannot use jacket water for the question.
Okay, bro. Okay.
So we were talking about the main bearings lubrication, right? So main bearing is basically fitted between the crankshaft and lower end of the connecting rod, bigger end.
Yes, in the journal thing.
Yeah, yeah. And how exactly lubrication is happening? You said wet lubrication, right?
Hydrodynamic.
Hydrodynamic, okay. But
I have shared
isn't
your picture.
bro? We have shared
Wait, wait. This right. This is your shaft. Okay. This one. Can you see my screen?
Yes, 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 yes.
This is a shaft. And this is the bearing. This is the main bearing.
Okay.
And this yellow color, right?
Mhm.
That is the lubrication oil. Hydrodynamic lubrication.
Okay. So yeah.
Whenever the shaft
It's
rotates, it achieves a gap between the lube oil and the bearing. I think you didn't get it.
uh, yeah, I get it actually. There will be oil film present between this and during the rotation. So, but my only doubt is, uh, what, this oil is same oil which is provided in the sump, na? Or there is any special provision given to supply oil at
No, no.
that?
From the sump, the pump is taking suction and give it to the passage. There is a
Okay,
passage.
okay, okay.
After
Yeah,
remaining oil will be go to the sump. The
okay,
lubrication won't take from the sump.
okay, okay, okay.
For main bearings, if you're talking about the four-stroke splash lubrication, the cylinder is cooling by the splash lubrication, not the main bearings.
Okay, so even in four-stroke engines, the main bearings are being not being lubricated by flash, right?
No, they are pumped
Okay.
at a certain bar, I think 7 to 12 bar, by the gear pumps, pumped into the passage of holes to the main bearing journals. It will achieve hydrodynamic lubrication.
Okay. Thank you for the explanation. Uh, then the next question is size of using base control that we can't. The next is parts of diesel engine we have discussed before. Purpose, purpose of compression rate. So as I've talked before, compression ring is there to ensure the proper feeding between the compression chamber and the engine. Okay. Ensures there is no leakage between the leakage of the compressed gases through the gap between piston and piston ladder. It is there to ensure proper feeding. Okay. Then how piston is cooled. Piston is cold. Okay. Next question is purpose of flywheel. We have discussed that before also, right? Okay. There is one question I would like to ask you, Jack. Why fluctuation is occurring in crankshaft? Can you discuss this one?
I think improper thrust bearings.
Improper thrust rate.
Mm. Or
So
improper compression.
how
Fluctuation
compression is
happens. Fluctuation happens during many cases. First is improper compression,
okay? How is that
and
going on?
what was the question asked?
The question is why fluctuation occurs in crankshaft. So you said because of there are multiple reasons, but one of them is improper combustion. Okay. So
Yes,
how improper combustion playing role in uh, fluctuation in crankshaft?
maybe poor scavenging, maybe leaky inject fuel injector,
Okay.
or improper exhaust valve closing.
Also,
So many cases are there.
okay, so these things are like imparting unnecessary stress on the compression crankshaft, right?
Yeah.
Yeah. So we can say because of improper combustion and along with other things, uh, crankshaft undergoes the stresses, and that's why fluctuation is happening.
Also, we can say variations in some pressures, also change in flow rate and variation in power supply.
Can
Your
you
voice
speak
is
a
too
little
low.
louder?
Voice is too low.
Am I audible?
Uh, Try to be a bit louder.
Yes. Also, we can say that variations in pressure, change in flow rate, and fluctuations in power supply. We can say. So this mainly causes the fluctuations in crankshaft.
Then working of
Fluctuation can
turbocharger.
happen during the overload also.
Yes.
Okay.
Yes. Overload also.
So this fluctuation is between the parallel faces of waves, crank wave.
Yes.
Yeah. Then why intercooler is present in turbocharger assembly? Basically to increase the density of the air which we are taking in. Okay. So the next question is how do you identify if your intercooler is working properly? I think this question is for you, Chen.
Exhaust temperature might be high.
Is working properly.
Working properly. What we can say? No problems with the main engine.
Yeah, of course. Is there any like monitoring done while the temperature of the inlet?
Yeah, there will be a temperature sensor on
So
the
if the
scavenge air manifold.
okay,
You can see the temperature.
okay. Yeah, so in the if the temperature coming of incoming air is right, then intercooler is working properly. We can say that.
Yeah.
So that's all about the IMS-GOA testimonials about IC engines. So anyone has any question? If anyone would like to add anything?
Can you explain about the Carnot cycle?
Carnot cycle.
Yes. Either you
Uh,
can or someone else.
Actually, I don't have it expression properly ready. But I have to look it up. Carnot cycle is not usually cast iron. Right. Anyone has expression for that? Would you be able to explain it? Okay, so Jack, I think we'll discuss that in the next session. Actually, I don't have answer prepared for that Carnot.
Okay.
Yeah.
So my next question was why we need use slow speed engines or why we use reduction gear in four stroke as a propulsion, as for the propulsion.
Okay, I'll answer your first question. Why do we need slow speed engine? So, slow speed engine provides more torque, which is required for the propulsion of the ship. So that's why we need slow speed engine because the propellers which we are using perform better, at a better efficiency when the engine is running at slow RPM.
Why we are using reduction gear in the four stroke when we are using as a propulsion?
Sorry.
Why we are using reduction gear when we are using four stroke as a propulsion?
I think for the same reason because we need slow speed engine for we need slow speed engine for the propeller. That's why we have to use reduction gear.
But mainly two-stroke engine are the low-speed engine, right? And four-stroke engines are high-speed engine,
Yeah, yeah.
Medium speed engines.
medium-speed engine. Yes.
Do you have better expression for it, Jack?
So I guess reduction gears are required in four-stroke engine because they are speed engine. And two-stroke engines are we know that they are low-speed engines.
Yes.
If you are turning the propeller so high,
Yes,
water
for
slippage
Cavitation.
will be more.
yes.
Chances of cavitation. Yeah.
Cavitation, slippage of water.
Yeah. That's why the efficiency of propeller decreases at higher speeds because there is the slippage and cavitation.
Yes.
Yeah. I forgot about that. Thank you. Okay. Anything else?
You have any questions I shall answer?
Yeah, there's one question. Have you heard about diaphragm in engine?
Diaphragm.
Yeah.
It's in the two stroke below the stuffing box.
Uh, can you just tell something about it? Or we have a diagram or something?
Diaphragm is used to separate the combustion chamber and the crankcase.
So is it a part of like again gland packing or what?
It's like a single plate with a hole inside to move the piston up and down.
Okay.
It separates the combustion chamber and the crankcase
Okay.
below the stuffing box. You're searching for something, right? What was it?
Yeah, I was searching for the diagram for that diagram. Just turned off the recording. Check if you have like a image or diagram or anything that can you please share it?
Right now, I don't have. I have to search in Google.
If you find anything, just feel free to share it on group. Okay.
I will find lately and send it to you personally.
Yeah, sure.
If I get it from Google, I don't know it is correct or not.
Yeah, I also find it on Google. It is a similar thing. I mean, it is presented between the presented with that stuff like gland packing or stuffing box. So it
Yes.
separates the it prevents oil from getting into the combustion chamber and leakage of combustible gases into the crankcase.
Yes, I have also found same image.
Yeah. So I think that's it for today.